Hi all. So in this section, we'll show you how to deploy your DLT pipelines with Airflow. So before we get started, you should know that at this stage, you should be able to run the code that we showed you in the previous case study. If you can't, please head back to that section and do so. In that, we'll show you the code for collecting data from GitHub and storing it in GCP's BigQuery. Naturally, that means you'll also need access to GitHub and GCP. You'll also be needing Docker Desktop. So this is going to be for the latter end of this section where we actually deploy our Airflow DAG to the cloud. With that out of the way, let's talk about what we'll be covering. First, just going to give you a general overview of Airflow and some of the terminology and concepts. Then I'll show you how to set up your Airflow project, and then we'll do the actual deployment, first in the local machine and then in the cloud. So Apache Airflow, as the name suggests, it is an Apache project, so it's open source. It's one of the older orchestration projects in the market, and at this stage, it boasts a massive community and it has a huge library of operators, so it's capable of facilitating a variety of different tasks. And it's basically viewed as the industry standard. So if you're watching this course and you're unsure of, which orchestrator you should start with, then Airflow is not a bad pick. So let's talk about some of the core components in Airflow, and you'll hear me maybe use some of these words every now and then during the actual demo. First is the scheduler. You can think of it as the brains of Airflow. It basically decides which DAGs to run and when. Your executor is the muscle. It basically facilitates the actual runs. And then we have the web server, which is the name of Airflow's UI. You'll see later on that we'll be doing a lot of the interaction with Airflow through the UI itself rather than the CLI. That's just my personal preference. In Airflow, workflows are represented as directed acyclic graphs, or DAGs for short. So the workflow on the right is, just an example of what that would look like. And these DAGs comprise tasks. Tasks are basically individual units of work, and each task is created with an operator. So an operator is basically a tool provided by Airflow to carry out a specific task. For example, if you want to run a Python function, you would use a Python operator provided by Airflow. If you want to run a shell command, you would use a bash operator, and so on and so forth. Here's what an actual DAG will look like, or at least how it's visualized in the Airflow web server. So here we have 4 different tasks, A through D, and you can see that each task is represented by a rectangle. And under each task, you can actually see what type of operator is used to run it. So in this case, you can see that they are all run with the empty operator. Now, as the name suggests, an empty operator doesn't actually do anything. It's more of a placeholder, but this is just an example. The lines between the tasks denote order and dependency. So for example, tasks B and C won't run until task A is done running, and and D will only run when C and B are done running. But now let's talk about how a DAG script actually looks like in Python. I should let you know in advance that for DLT, you really don't have to create any DAGs from scratch, but it will definitely help you to understand some of the main functions and parameters that are used in Python for Airflow. So first, of course, we create the DAG itself. This can be done with a context variable with the context window, as you can see here, or it can also be done with a DAG decorator. Either way, through the window or through the decorator, you give it your DAG its ID. In this case, it's demo DAG. You define the start date, as in the date that the DAG can start, and then the schedule, i.e., how frequently your DAG should run. Within the DAG itself, in the code block, we are defining all the different tasks. So in our case, we want to do extract, normalize, load, much like any ETL process. So our first task is extract, and we create it using the Python operator. We do the same for normalize and load. So 3 tasks are created with 3 Python operators. Now that we've created these individual tasks, we actually want to link them in order to establish order. So in Airflow, that is denoted by double arrows, as you can see here. Using double arrows, we can tell Airflow that after running extract, we want to run normalize, and after normalize, we want to run load. If you want to deploy your DLT pipelines in Airflow, you should understand that there is one major obstacle, and that's that DLT and Airflow are inherently different and they have different environments. As a result, they're not perfectly compatible. Let's talk about why that's a problem. If we were to deploy our DLT script as is, the DAG in Airflow is going to look something like this. Not complex at all, right? It's literally just one task, DLT pipeline.py, which means that if we run the DAG, it's going to just run the script as is. And that's a problem because we can't, with this arrangement, leverage all of the features that are offered by Airflow, such as parallelization, in which we can basically run each endpoint concurrently. So as a result, what we need is a way to bridge the gap between DLT and Airflow, such that we can have Airflow interpret DLT pipelines the same way that DLT interprets DLT pipelines. Now, thankfully, that requires no effort on your part because we've already created that bridge in the form of a helper script. It's called Airflow Helper. I want to take a quick minute to introduce you to the Airflow Helper script, and then we can talk about its implementation. So as you can see, we're at the DLT docs page. I'm going to search for Airflow Helper by just typing that in, and it'll be the first result. So if you click on it, there'll be a page that introduces you to the script, including the objects and functions that are within the script. If you scroll down, you'll see that for each function, for example, there'll be a description of what it does and some of the arguments that you would be provided for each function. And if you are interested in the entire script as is, then you can just view the code in GitHub by clicking on this link, and you can just see the entire code. So in my case, we won't actually have to integrate the helper from scratch because the CLI commands that we use will do it for us, but we will at some times, tweak the parameters for different reasons. Specifically, I'll be working with the add run function here, and you'll notice that I kind of tweak around some of the parameters. For that reason, it kind of helps me personally to familiarize myself with the functions so that I know how to make changes to the pipeline in Airflow when I want to. So in your case, if you just want to follow along the demo, then you don't have to worry about this too much. But if you want to branch out, if you want to add more to your pipeline, or if you want to just go in a completely different direction, then I definitely recommend you just take a minute to look over this script. First, let's look at how DLT actually, runs behind the curtain. If you paid attention to the logs when I ran the pipeline in the previous section in the case study, you'll know that, this is how DLT works. So let's say that we have 4 resources that we want to collect data from. Well, a DLT pipeline is going to extract the data from all 4 resources first, then it's going to normalize the data from all 4 resources, and then it's going to load the data from all 4 resources. Well, with the Airflow helper, we go from this arrangement to this, where rather than extracting everything, normalizing everything, and loading everything at the same time, we are working from one resource to the next. We extract, normalize, and load for one resource, and then we move on to the second, the third, then the fourth, and so on. And the reason this is an important change is that we can now leverage parallelization, which with the Airflow helper looks like this. Now, you'll notice from the beginning that something looks off, right? If the four resources, you expect them to be running all at the same time concurrently. Well, this is how Airflow Helper does it. And I should point out that this is a feature, not a flaw. So by processing one resource on its own, we're able to define our state and schema. And after we do that, for security, we can then move on to parallelize the remaining resources. You'll see this actually done when we deploy our actual Airflow DAG in parallel.